All right, so it's day 2. It's our last part, part 2, rational inequalities. So we have this inequality here, but it's a rational inequality. So with solving inequalities, we follow the 4 steps I gave you last time of set to 0, factor to get your critical numbers, place your critical numbers on a number line, and test the values to satisfy the inequality. So before we do that, we need to get rid of denominators, eliminate denominators by multiplying it by the lowest common denominator, or LCD. There you go. By LCD. So we take any of the denominators and we list them over to the side so we can multiply back. So I have x minus 6. So I'm going to multiply by x minus 6. And I have an x plus 1. And then since the 0 is not a fraction, I like to make anything look like a fraction by putting it over 1. But we aren't concerned about the 1 when we're looking for a lowest common denominator. So there it is, the lowest common denominator. So we're going to multiply it by the first piece. And when we multiply, we have an x minus 6 here and an x minus 6 here. Those will cancel. So we have 4 times x plus 1. Plus, and multiply the LCD times the second part. In the second part, there's an x plus 1 in the denominator, and it will cancel this x plus 1 in the LCD. So we have 2 times x minus 6. We have a greater than symbol. And then the LCD times 0, well, anything times 0 is 0. All right, so we simplified our inequality by canceling out denominators. Now we're just going to multiply out. Distribute the 4. So we get 4x plus 4. Distribute the 2. We get plus 2x minus 12. It's greater than 0. Combine our like terms. 4x plus 2x gives us 6x. Positive 4, negative 12 gives us negative 8. Is greater than 0. All right, we're looking for critical numbers. So we're going to take this, and I'm just being technical here because it's an inequality symbol. But we want to find critical numbers, so we're going to use it. We're going to make that an equation. We're going to set that 6x minus 8 equals 0. So add the 8, divide by 6. X would equal 8 over 6. But we want to simplify that. So x equals 4/3. And that is a critical number. That is a critical number. Remember, the critical numbers are the values we put on the number line. So we can test different sections to figure out the interval for our answer. So I'm going to draw a number line, and I know I'm going to put 4/3 on the number line, but I don't know where it's going to go yet because, hold on, before I do that. What is also critical would be anything that would make the denominator equal to 0, because we can't have a denominator equal to 0, right? Because that would be impossible to divide by 0. So anything that would make that happen is also critical. So we have denominators. That's what's new for today with this example versus what we did last Wednesday. Is we didn't have any denominators, so we didn't have to worry about that. But we cannot let our denominator equal 0, so we have to take x plus 1, set it equal to 0, and that gives us x equals negative 1. That is a critical number. And then we're going to take our other denominator, and we do this for as many denominators as we have in the original problem. X minus 6 equals 0, which tells us x equals 6. Well, I guess I can write it backwards. x equals 6 is also critical. So I have 3 critical values that I need to place on this number line. Left to right, -1 is going to be the smallest one. There's only one negative. It's -1. So I'm going to put that on here first. -1. And then I have 6 and I have 4/3. Well, 4/3 is like 1 and a third, and 6. So 1 and a third would be smaller than 6. So that comes next. 4/3. And then after that would be the 6. So make sure you get them in the correct order. And that's what splits up our number line into intervals to check. So I have this one, and this one. And we know over here on the left is negative infinity, and on the right is positive infinity. All right, so if we look at the 4/3, figure out if it's included or not included in our answer interval, it came from this part that was greater than 0, so that's not included, right? That would be an open dot or parentheses. So at 4/3, I know 4/3 is going to be open because it comes from this symbol. Now the critical values that we got from the denominator, the symbol in the inequality doesn't really affect that at all. These, we know the denominator cannot ever equal 6, because if the denominator equals 6, it means you divide by 0 here, and you can't do that. So anytime you get critical numbers from denominators, they're never going to be or equal to. So I'm going to put an extra little note here. Critical numbers, CNs, from denominators are never and I'm just going to do parentheses, in quotes, or equal to. You can word that however you need to. You could say they will always have parentheses. They will never be included. However you want to word it to where it makes sense to you. So both of those critical numbers are open dots. They cannot be those numbers, because I got those critical numbers from setting denominators equal to 0. Okay, so then moving on with solving the inequality, after we have a number line with our critical numbers on it, we need to choose test points to test. I need to test the interval to the left of -1. So I need to choose a value that's smaller than -1. I'm going to go with -2. And I'm going to plug into my original problem that I wrote at the top of the page, or the one that is printed on your paper, however you want to look at it, printed in the book. So I have 4 over -2 minus 6 plus 2 over -2 plus 1 is greater than 0. If I calculate on the left, I did this one as a decimal. I didn't do them all exactly the same. But this one, if I calculate that on the left as a decimal, my calculator tells me -2.5 is greater than 0. -2.5 is not greater than 0. A negative will never be greater than 0. So this section fails my test. It will not be part of my answer. So then I move on to the next section. I need a value between -1 and positive 4/3. Anytime I'm choosing a test value between a negative and a positive, I'm going to choose 0, because it's very easy to work with. So I plug in and I get -4 over 6 plus 2 over 1 is greater than 0. And that gives me 4/3 is greater than 0. Positive 4/3, yes, is greater than 0. So this middle section checks. It is going to be part of my answer interval. So then I move on to my next section. I need a number between 4/3 and 6. Doesn't matter what I pick, I'm going to pick 2, positive 2. So I plug into my original problem. It gives me 4 over negative 4 plus 2 over 3 is greater than 0. So on the left, it gives me that if I calculate on the left, it's negative something. It doesn't even matter what it is, just it's negative. And a negative greater than 0, negatives are never greater than 0. It was actually negative 1/3. But just showing you that it doesn't matter when you're testing your values if you use a decimal. If you just compare if it's smaller or larger than 0, and this one's negative, and a negative is never larger than 0. So this section fails. So then last, I need a number bigger than 6. I'm going to go with 7. Plug in 7, and I get 4 over 1 plus 2 over 8 is greater than 0. So it gives me, if I calculate that, that's a positive number. I don't even have to calculate it. I have a positive plus another positive. So I know this is going to give me a positive value. A positive is greater than 0. Yeah, positives are always greater than 0. So I don't even need to calculate that. Just be careful if you do it this method, because maybe over here on this one, that would have been a little more complicated. Negative plus a positive. It did give me a positive, but you just have to be careful with the numbers. Or go ahead and calculate it out. I mean, you just type it in your calculator. So I see I have 2 sections that will be part of my answer. And don't be fooled with a pattern. Trying to look for a pattern is no, yes, no, yes. That's not necessarily true. It could have been no, yes, yes, no. It could have been no, no, yes, no. I mean, just because it looks like there might be a pattern doesn't necessarily mean there's a pattern. All right, so now I have my checks done. So I know my critical numbers. This section's not included, so this is the first one. The beginning of this interval starts at negative 1. So my answer starts at negative 1. It goes from negative 1 to positive 4/3. Negative 1 came from the denominator equaling to 0, so that's not included. It will never be included if it makes the denominator 0. 4/3 came from solving, but this symbol in my problem was not an or equal to, so that is also not included. There's another interval, so I have to do in union with. And then I jump to the next interval that's part of my answer. It's a 6. The 6 came from a denominator equal to 0, so I know it's not included. Parentheses 6. And then from there it goes towards infinity, and I know infinities are never included. So there is my answer.
So, for the section between 4/3 and 6, I used 1 as my substitute number, and I got a positive.
But 1 is not bigger than 4/3.
Yeah.
So you do have to be very careful about the values you choose.
Okay.
It's a good example of that. We're still in the same homework, page 145, but now it's numbers 19 through 27 odd.